Okay, so I'm going to go over the M4 Trig and Pythagoras assessment. I encourage you to go through this with your test beside you and also make any corrections that you need. Okay, so first thing I'm going to do, question 1, this is criterion A. So we have to calculate the length of AB. Okay, so let's call this X. Label our sides. Here's our angle. This is our opposite. This is the right angle, so this is the hypotenuse, which means that this side left over is the adjacent. I'm going to write down at the top, SOHCAHTOA. Tick what I know and what I want to find out. Okay, so I know the hypotenuse, and I want to find out the adjacent. So I'm going to use cos. Now the formula for cos is cos of the angle equals adjacent over hypotenuse. Okay, cos equals adjacent divided by hypotenuse. So cos of 28 equals adjacent over 8. Okay, what is the 8 doing to the x? Okay, it's dividing, so if I want to bring it over, I have to multiply. So I'm going to multiply both sides by 8, multiply by 8. So I end up with 8 multiplied by cos 28 equals x. X equals, let's go down and get our calculator. Eight cos 28 equals 7.06. Let me just double check that. Yep, and that is to 2 decimal places. Okay, let's move on. Question 2. We need to find the unknown side marked with the question mark. Just going to change color. So again, we label our sides. This is what we want to find out. Here's our right angle, so this is our hypotenuse. This is the angle we know, so this is the opposite side. This is the adjacent. So again, using our SOHCAHTOA, we know the opposite. We want to find the hypotenuse. So I've got 2 ticks beside sine. Formula is sine of the angle equals opposite over hypotenuse. So sine 35 equals opposite, which is 3, divided by hypotenuse, which is what we want to find out. Now we've got x on the bottom here. So if I bring, this x is dividing into the 3. So if I bring the x up, I'm going to have x sine 35 is equal to 3. So x is equal to 3 divided by sine 35. So most of you probably went from this line to this line, which is fine. And again, we put it into our calculator. So 3 divided by sine 35, and we get x is equal to, I missed that, 5.23. Just tidy that up. Okay, so our unknown side, the question mark, is 5.23 centimeters. So again, making sure you get any corrections marked in on your paper. Right, this time finding the size of the angle x. Again, same steps. This is our angle, so this is our opposite side. This is the right angle, so this is the hypotenuse. The one left over is the adjacent. So, SOHCAHTOA. We know the adjacent and hypotenuse. So I'm going to use cos because I've got cos of, because I've got both the adjacent and the hypotenuse. So again with the formula, cos of the angle equals adjacent over hypotenuse. Okay, so cos of the angle is x, that's what we're trying to work out. Adjacent is 3.4, hypotenuse is 5.2. Okay, now this time we want to find out what the angle is. So in order to get x by itself, I need to do inverse cos. Alright, so x is equal to, and I put this straight into my calculator exactly as it is. Now, to get inverse cos in your calculator, it's this one, okay? So I have to do second cos 3.4 divided by 5.2 equals, and I get my angle 49.1. Okay, and I'm going to round to 1 decimal place. Actually, you know what? If we were drawing an angle, I would draw it to the nearest degree. So I'm going to give this to the nearest degree, which would just be 49 degrees. Excellent. Okay, so moving on. Come on. Doesn't want to do it. Right, by using the special triangles, find the unknown measurements. Leave your answer in exact form, as assert if necessary. So our special triangles. Okay, Mr. Judd is emailing me. So our special triangles are the following. If I draw them out, this helps us remember. So this is 60. This one is 30. This is 1, 2, root 3. Okay, so this helps us remember any sine, cos, or tan of 60 or 30. Okay. So working through it as we would before, this is our angle. So this is our opposite. Here is the right angle. So this is my hypotenuse, and this one is my adjacent. So I want to find out what E is. So we start off as before. I know this side. Is my pen not working? Oh, okay, there we go. Okay, so I know this side. This is the one I want to find out. So again, looking at our SOHCAHTOA. Adjacent hypotenuse. Two ticks by cos, so I'm going to use cos. So cos of the angle is equal to adjacent over hypotenuse. So cos of 60 is equal to adjacent, which is E, over hypotenuse, which is 4. Now, if I wanted to work out what E is, the 4 is on the bottom, so in order to get rid of the 4 on that side, I have to multiply both sides by 4. So I'm just going to switch these around, so I'm going to have E equals 4 multiplied by cos 60. The thing is, I don't want to leave it like this, and I don't want to put this into the calculator because I have to leave it in exact form, okay, as a surd. So looking at our special triangle that you needed to remember, or you could just remember what cos 60 is equal to. Cos of 60 is equal to, well, cos is adjacent, so this is my adjacent, this is my opposite, this is my hypotenuse. Cos of 60 is adjacent over hypotenuse. So I'll just write that down. Cos of 60 is equal to 1 over 2, which becomes quite nice actually. So I've got 4 multiplied by a half. 4 multiplied by a half is 2. So E is equal to 2. Now I do need to see this triangle, okay, in order to get the marks. If you just put this straight in your calculator and got a half, I'm afraid that's not good enough. We need to see the triangle, okay? Now this one, the 2 little dashes, what does that mean? It means that both these sides are the same length because it's an isosceles triangle. This side is the same length as this side. So I can write down straight away that G is equal to 6. Alright, if G is 6 and I need to work out what H is, I can use, I've got 2 sides, I don't know this side, I can use Pythagoras. And I'm trying to find the longer side, so it's going to be addition. Alright, 6 squared is 36, 6 squared is 36. H squared is 72. So H is equal to the square root of 72. Now, 72 is the same as, say, 9 times 8. Okay? So H is equal to the square root of 9 times the square root of 8. What's the square root of 9? It is 3. So square root of 72 is the same as 3 root 8. Now also, 8 is the same as 4 times 2. So H is equal to 3 multiplied by, and I'm going to use a different color just to make this hopefully a bit more obvious. So if this is the square root of 8, oops. So you know what, let's just do this. I'm just going to write this in a different color so you can see which things are the same. So the square root of 8 is the same as the square root of 4 times the square root of 2. Now the square root of 4 is equal to, square root of 4 is 2. So I've got 3 times 2 times root 2. So my final answer is 3 2s are 6 times root 2. Okay, and if you get down to here, that's good. Okay, you cannot write it as a decimal. Okay, it has to be as a third. But really what you're aiming for is to get it down to here to get full credit, okay? That is what we're after. We can check it. If I put the square root, where's my square root button? Okay, square root of 72, 8.48. And if I do 6 square root of 2, I get exactly the same thing, okay? So this answer, let's go to a different color. So this answer is exactly the same as this answer, except this one is more simplified. And you should always be aiming to simplify your answer as much as possible. Okay, so moving on. Alright, so same drill. Here's our angle, so this is our opposite. Here's the right angle, this is the hypotenuse, and this is the adjacent. So, take what we know. I've got SOHCAHTOA, adjacent and hypotenuse. I'm going to use cos. Oh, that's a bit nice again. So cos of the angle is equal to adjacent over hypotenuse. Cos of what angle is equal to 3 divided by 6 is a half. And again, you can't use your calculator. I want to see evidence that you've used this triangle. Cos of 60 is equal to a half. Okay, so now we start to move on to the more complex questions. Diagram shows a roofing frame, A, B, C, D. We've got all the measurements given and a couple of the angles. Calculate the length of AD. So we're after this length here, A, oops, to D. That is the length we're after. Let's call it X. Okay, I've got another two sides here that I know. That's 3. This one's 7. So I can use Pythagoras. I'm trying to find the longer side because it's opposite the right angle. So I can use x squared is equal to 3 squared plus 7 squared. Okay, and so x squared, it's stopped. Come on. Just wait for it to catch up. There we go. Right, so x squared is equal to 3 squared is 9, plus 7 squared is 49. 49 plus 9 is 58. X is equal to the square root of 58. Which, if I'm going to put it into the calculator, square root of 58, 7.6. 7.61577. 7.61577. And I'm writing it out to quite a few decimal places because I don't want to affect my rounding for the next question, okay? However, I'm going to use this answer, square root of 58, in order to work out B. So calculate the size of angle DCB. I'm going to use a different color. So there's D, to C, to B. So this is the angle in between those. This is the angle I want. Let's call it Y. Label my triangle. This is the angle I want, so this is the opposite. This is the hypotenuse. This is the adjacent. Looking at SOHCAHTOA, I've got opposite and the adjacent. And so I'm going to use tan. So tan of the angle, tan of Y, is equal to opposite, which is 3, over adjacent, which is 5. So in order to find Y, I'm using inverse tan, which is 3 over 5. So Y is equal to 30.96. So I'm going to write that down. And because it's an angle, I'm going to give it to the nearest degree, so 31 degrees. Now going back to this part A, if you did round it, we're dealing in meters here, and it's a roofing frame, so we want it to be fairly accurate. I'm going to round it to the nearest centimeter. So 7 meters, 62. Okay, because the 5 makes the 1 round up to a 2. So either this answer or this one. Okay. Diagram represents a building 30 meters tall. Flagpole stands. The flagpole DC stands on the top of the building. So this is a flagpole. Okay, we're given the point of elevation from A to the top of the building is 31, so that's 31 degrees. And the elevation to the top of the flagpole is 37, so that is 37. Calculate the height of the flagpole. Alright, so we've already got this distance. If I can find the total distance, let's go to green again. If I can find the total distance, whoops. So the distance from the top to the bottom, let's call that x, and I can subtract off this distance of 30, give me the part left over. So in order to find x, I'm going to use the full triangle. If I'm using the full triangle, then the angle that I'm using is 37. So here's my right angle, this is my hypotenuse, this is the angle, so this side is the opposite, this is my adjacent. Okay, so what information do I have? Actually, I've only got not enough information. I need another side in order to be able to work out what x is. So let's back up and look at, okay, there we go. Let's look instead at this triangle. Now I can use this triangle, because I know this length, I know this angle, in order to work out this side. Okay, so let's do that. So this side is, so there's the angle, so this is the opposite, this is the adjacent, this is the hypotenuse. I know the opposite is 30, I want to work out the adjacent. Opposite and adjacent, tan. So tan 31 is equal to opposite, which is 30, over adjacent, which is y. Now, because y is on the bottom, I'm going to have to do 30 divided by tan 31. Which is 49.93. Okay, so this is 49.93. Okay, now I'm going to go back to my big triangle. I'm going to go back to the large triangle. Actually, let's use a brighter color than that. Let's use green. I'm going to look at this triangle. And this time I'm using an angle of 37. So again, this side is opposite 37 degrees, so this is the opposite. And I now know this side, which is the adjacent, because this one is the hypotenuse, because it's opposite the right angle. So again, opposite and adjacent, I'm going to use tan. So tan of the opposite tan of the angle 37 is equal to opposite, which is x, over adjacent, which is what we just worked out, 49.93. So x is equal to 49.93 multiplied by tan 37. So the x is equal to, so I'm going to use this straight from the calculator. So I'm just going to hit times tan 37, 37.623, 37.624. Okay, so we're almost done. So flagpole height is equal to the total distance of x, 37.624, minus, so it's a total height, which is what we just worked out. This is 37.624. Subtract off the height of the building, which is 30. And that leaves us with what's left over, DC. So again, I'm using the answer that's in the calculator so I don't mess up my rounding. Subtract off 30, which equals 7.62. All right. So make sure you get any of this copied down that you need. Okay, you can always come see me if you have any questions, queries, or if you need anything explained further. So moving on. Find the length of side x. Okay, now looking at this, I've got a big triangle here. I know this side. This is what I want to know. So if I can work out this and this, then I can use Pythagoras, okay, to work out x. So I'm going to look at the small triangle first. I'm going to look at this blue one. So this is 57. This is 5.8. And I want to work out this side. Okay, let's call it x. So I've got, this is my opposite. This is the hypotenuse. This is the adjacent. I would want to find the adjacent. I know the hypotenuse. ANH K. Cos of 57 is equal to adjacent over hypotenuse. 5.8 is dividing the x, so I need to multiply both sides by 5.8. So x is equal to 3.1589, so 3.16. Okay. So that is x. That is 3.16. Next, let's use green again. We're going to look at this triangle. Now, in order to work out this length on this triangle, I need more information. Unfortunately, I also need to work out what this length is. Okay, because if I know this, then I can work out this length, okay? So going back to this triangle, let's call this one y. Okay, I know that this side is 3.16. I know this side and this side, so I can use Pythagoras to find out y. Okay, so I'm going to use Pythagoras now to find this side. Now, we look at this, is y the longer or shorter side? Okay, well it has to be the shorter side because this one is the longest because it's opposite the right angle. And if it's shorter, that means when we're doing Pythagoras we have to subtract. Okay, so going to our calculator, 5.8 squared minus our previous answer squared, and then I'm going to 23.66. So y is equal to the square root of that. .86. So this side is 4.86. Okay, now I'm going to look at this triangle. There's a lot going on in this question. Okay, now I want to work out this side, so let's call it Z. I've got the angle here. So let's draw this out. This is 4.86. This is 22, and this is the side I want. Let's use a different color. This is my opposite, because it's opposite the angle. This is my hypotenuse up here, because it's opposite the right angle. This is my adjacent. Adjacent and opposite, I'm going to use tan. So tan of 22 is equal to opposite over adjacent. So z is equal to, okay, z is on the bottom, so I need to divide. So I've got 4.86 here in the calculator already, just divided by tan 22, which equals 12.04. So this length is 12.04. So the total length of this big triangle, this side is 8.4. This is what we want to work out. This is 3.16 plus 12.04. $15.1995. So let's say 15.2. Okay, so I'm going to use Pythagoras. Let's use a different color, purple. Trying to find this side, which is the shorter, because this one is the longer one. So again, I have to subtract. So 15.2 squared minus 8.4 squared is equal to x squared. Let's put it straight into the calculator. I've already got the 15.2 squared up here, or 15.2. I square it, subtract off 8.4 squared equals 160.4. Let's put 47, 2 decimal places. Okay, but I use the answer in the calculator again to figure out the actual answer, okay? So square root of previous answer equals 12.6, and I'm going to round this to 2 decimal places, so 12.67. And that is our final answer for that question. Okay, there's a lot going on there. Okay, we're working with 3 different triangles. Nathan is over on the east side, distance of 2.5 kilometers. So the first thing we notice is that this is in meters and this is in kilometers. First question, write the depth in kilometers. So you should be aware that there's 1,000 meters in 1 kilometer. So if I want to work out how many kilometers 1850 meters is, we're going to have to divide by 1, 2, 3, divide by 1,000. This is something that you need to remember. So divide by 1,000, I get 1.85 kilometers. Now our units are the same, so that's all good. On the diagram, label the angle of elevation from N to M. N to M with an X. Always measured from the horizontal. This is X. Not very well labeled. Okay. Find the size of the angle of elevation. So I'll do my working just up here. So this is the angle I want to find. So this is my opposite. This is the hypotenuse. So that's a right angle. So this is the adjacent. I know the opposite. I know the adjacent. So I'm going to use tan. Okay, this all comes back from SOHCAHTOA. So tan of the angle is equal to opposite 1.85 divided by 2.5. We're using the same units. We're working out the angle, so I need to do the inverse of this. Second tan 1.85 divided by 2.5, 36.5. And again, because we're working in degrees, I'm going to round it to the nearest degree, so 37 degrees. Okay, last part. Find the distance in kilometers between Mary and Nathan. So this distance, let's use a different color. Y. Let's use an even differenter color. Let's use purple. Okay, so we've got ourselves a right angle triangle. I know this side, I know this side. So I can just use Pythagoras. I'm trying to find the longer. So I'm going to use addition. So y squared is equal to 1.85 squared plus 2.5 squared. Put that straight into my calculator. Oops, just checking as you go. 2.5 squared, 9.6725. Find the square root. Square root of my answer, 3.11. And our answer is in kilometers. Now, does the answer make sense in relation to the rest of the problem? Well, we would expect. So I'm just going to type something here, make it easier. I'm going to put yes, yes. The answer does make sense, as I would expect the distance between Mary and Nathan to be longer than the distance between Mary and, is it Peter? Yep. Or Peter and Nathan. This is because the distance between Mary and Nathan is the longest side of the right-angled triangle. We know this as it is opposite the right angle. Okay, something along those lines. Okay, just explaining why you think the answer is. So yes, the answer does make sense. We expect the distance between Mary and Nathan to be longer than the distance between Mary and Peter, or Peter and Nathan. This is because the distance between Mary and Nathan is the longest side of the line. Okay. So yes, it does make sense. If I'd gotten an answer smaller than 1.85 or 2.5, I know I would have done something wrong. Okay, last, explain the degree of accuracy. So this, I want to put something along the lines of the answer may not be 100% accurate, as we are assuming there is a right angle between the ground and the canyon. Okay, so we're assuming that this is a right angle. In reality, it is probably not. We are also assuming that Mary is directly above Nathan, Peter, and in reality, it probably would not be the case. Okay? Gotta think, this is a canyon, this is supposed to be a real life example. Mary is probably, if she's in the Grand Canyon, sitting at a height of 1.85 kilometers, in reality, she's probably not directly above Peter. This might be a little bit over here, or it might be a little bit over here. This, in reality, is not a right angle, because it is, it's a canyon. Okay, it would be very difficult. These are not straight edges. And we'll also put, just for the sake of it, because we can, the measurements between the three people are not exact. As they are not forming a perfect right-angled triangle. So that's the type of thing. Okay, we want to just comment on whether the answer is, accurate as we'll put however our answer makes sense in the context of the problem. Okay. So just commenting on the accuracy and whether you think, does this make sense? Okay, why might it not be 100% accurate? And that's really common for the E assessment.